Hi, good morning, everyone. So today is Tuesday, March 16th. When you open your period 2 or period 3 stream, you are going to see the directions for today. You'll see the times that your class period starts, just like yesterday, and you'll see your assignment today. You have one assignment called number 9, Atmosphere Text Analysis. This is a text with questions, and there's also a screencast reading it to you to help you answer the questions. So I'd like to just review yesterday and make sure that you understood a little bit of those actively learned assignments. So I'm going to go ahead and close this. Yesterday in your classwork, you saw number 7 and number 8. Number 7 was an article and questions about pressure and density, which we spent all last week kind of talking about density a little bit. And then the second one was the first 2 layers of Earth's atmosphere. So hopefully when you got into the actively learned, the very first one that you saw was pressure and density in the atmosphere. So try to flash back to our convection demonstration last week when we put the food coloring into the hot water, how quickly it moved because of the water being less dense from the air being heated. So when the water and the air, or liquids and gases, are heated, they become less dense. This also happens in our atmosphere. So as you read through this, you saw a little information about air, you saw a reminder and a more formal definition of density. I like the second part there that says density is a measure of how closely those molecules are packed together. That helps maybe give you a little bit visual. And here we're talking specifically about the density of air in our atmosphere. So your first question, it asked when air is warmed and becomes less dense, it moves upward until it cools and then it sinks again. And the name of this is convection. So you saw this and you drew it last week in the lab. Then we had altitude and density. Altitude is your height above sea level. So you had to write what your altitude is depending on where you live. If you live right in downtown Littleton, it's likely that your elevation is about 5,200 feet. I live a little bit outside of town and live at about 7,200 feet. So hopefully you were able to look that up. So the point of you knowing that is this little paragraph here, to know that the density of the air, it decreases the higher that you go. So the air where I live is less dense than the air where you might live if you live in town. Then the question asked you why. Why is this? And your answer, again, is right above there. It talks about there's 2 reasons. At high altitudes, there's less air. So the Earth is a spherical shape. It's a circular shape. So as it goes upward, kind of angles out, and you have less air molecules the higher you go up. The further away you get from Earth's surface, there is also less gravity because you're furthest away from the center. So the explanation of that is kind of highlighted and summarized in blue below the question. Hopefully you read a little bit about air pressure. Air pressure is the weight of that air pressing down on you. So the higher up you go, the less air pressure that there is because there's less air molecules pushing down on you. So if you go to Florida or have been somewhere like sea level, you're going to have a lot more air molecules around you and pressing down on you than somewhere like here. So hopefully you got that question correct based on reading everything above it. And then your last little question here is about the water bottle. So the hiker, he screwed the top on the empty bottle at the mountain, and then he walked down the mountain, and the lower altitude crushed it. Hopefully you were able to say something about the number of air molecules being less the higher up he was on the mountain than down below as he came down. So you had a summary question or summary bullet points to help you understand the article, and you had a good couple of minutes of a video to give you some visuals in addition to the text and explanation to help you understand the difference there. This is especially important where we live, as you guys know. So hopefully you were then able to write one thing that you didn't know before and have your 6 questions answered for air pressure and density. The next actively learn that you did was on the troposphere and the stratosphere. So this was your first official introduction to the Earth's atmosphere. Now we're going to do this next week in class, of course, more in depth, okay? So this is an introduction. So this first article just kind of gave you an overview of an introduction to the atmosphere, and then it jumps right in here to our first level. So the first layer of Earth's atmosphere is called the troposphere or troposphere, I've heard people say also. So it introduces you to that. It tells us two important things. First, all the air that we breathe is in the troposphere, and all of our weather also occurs in the troposphere. Okay, so you may not have known that before, but weather doesn't take place all throughout the atmosphere, only in this lowest and most important layer. So again, we have all the air we breathe, the weather, and it's the lowest layer, but that's not the reason it's important. That's just a statement. So then we have properties of this troposphere. So the troposphere is the shortest layer, which means it's only about 7 miles from Earth's surface to the next layer, but it also, again, holds a lot of those gas molecules. Here in the troposphere, the reason we learned about heat all last week in the lab is so we could understand temperature and density. So in the troposphere, the temperature decreases with altitude. So the higher you go up, the less hot it gets. Okay, so the troposphere is heated by the Earth's surface, absorbing heat from the sun. Okay, that is a form of conduction. As the sun shines on the Earth and the Earth's surface, as you guys have identified, the oceans and the land heat up differently, but they still heat up, and that helps heat those air molecules that are in contact with the Earth. And then it gave you a little word problem. Talk about plane A is flying at 20,000 feet above sea level, and plane B is flying a little higher at 30,000 feet. And then which of the following statements are true? So temperature of plane A is colder, temperature of plane B is colder. Both planes are in the troposphere, but only plane A is in the troposphere. So we'll see what you guys have guessed. Now, 20,000 feet and 30,000 feet. We just talked about miles, so you might have to do some math to see how you would do on that one, or like some of you, you would guess. But we do know from our paragraph that temperature decreases with altitude. So the higher plane is not going to be as hot. So we can see if that plays out if both planes are in the troposphere. Let's see what it tells us. So we could have also picked the third selection to get that one correct. So we are correct in assuming that the temperature is colder on plane B, and we also needed to do a little math to see that both planes are still in the troposphere. The mixing of air was the next topic. So that kind of goes back to what I was talking about the Earth's surface being warmed from the sun. As it becomes warm, it rises, like we talked about density, and starts a movement of air in a convection cell. So last week you drew some circular patterns on your note sheet, and this is also happening in the troposphere at near Earth's surface. So we have conduction and we have convection. So it is warmest at the bottom layer closest to Earth's surface. And then we have some information about temperature inversion. So this happens when air is cooler close to the ground than it is above. So it kind of mixes a little bit, and it kind of gives you a really good example of how sometimes when that sun is out that we can have a little bit warmer air due to this kind of layer you can see here that acts like a lid and kind of holds some of the colder air near the ground. The tropopause is the name of kind of just the boundary right before we get to the stratosphere, which is the next layer in the Earth. And so you just had to write 3 things that you learned from this video. I don't want to do it for you, so hopefully you wrote your 3 things. I'm reading those. And then it gives you a little summary. And then you had another question, number 5. One of your classmates says the pollution from his car doesn't harm the environment because the exhaust is warm, and warm air will rise out of the atmosphere since it is less dense. So your friend is not correct because the troposphere is not the whole atmosphere. So when the gases come out of the car exhaust, they're not exiting the atmosphere. They're rising into our troposphere, into the gases that we breathe. Okay? So hopefully you were able to find the stratosphere by clicking the down arrow. If you weren't able to, you can do it today. So in the stratosphere, we have the number one thing there is that airplanes are flying in the stratosphere. The reason they do that is because there's less air molecules, so less friction against the airplane as it's flying. So the stratosphere is about 30, rises about 31. So from about 7 miles to about 31 is our stratosphere. Temperature here is different than in the troposphere. Temperature increases with altitude. So altitude is how high you go. So higher up in the stratosphere, hotter the temperature, different than the troposphere. So that would be that question. Whoops. So this is the one Nick Oliva was telling me about. I will make sure everyone gets this one correct on their paper, as he let me know that he clicked this and it did not give you the correct answer. The number one thing that's most important about the stratosphere is it contains our ozone layer. So our ozone layer consists of 3 molecules of oxygen. We're going to talk a lot more about this in class next week now, obviously, with periods 2 and 3. But the ozone layer protects us from the UV radiation of the sun. And this explains how that happens. Now remember, I've shown you this like a million times, but you can always hover over highlight something and see that it will read it to you by clicking on hear it. Okay? So just a little reminder on that. So this does a really good job of using text and pictures to explain to you how the ozone layer helps protect us and Earth from those harmful UV rays from the sun. It did ask you to go ahead and answer that question. How does the ozone layer protect us? So hopefully you were able to say that it acts as a barrier of some sort or it absorbs it. I'll be looking at those today. And then you have your stratopause. At the top layer of the stratosphere is your pause between that and your next layer. So we'll get to the next layer next week. And then you had question 8, how is that stratosphere different from the troposphere? So the temperature in the stratosphere increases as altitude increases. The troposphere is not closer to the sun, so we would not check that. Stratosphere has ozone, and there is no weather in the stratosphere. So let's see how those turned out, and we were correct. So one more little visual aid to help you look at the breakdown, the chemical breakdown of ozone and how it protects us. And then one thing you learned from that, so you only had to do one thing there. And then you are all finished with your assignment. So if you didn't get a chance to finish that, you can definitely go back through it today before you start on your second assignment.